So, my name is Maxime Markolenko. These are my teammates, Michael Baker, Ken Johnson, and Ben Stevens. And we put together the Geo-Tagging aerial system. What it is a mixture of computer and sensor networks that go into unmanned aerial vehicles, both helicopters and planes. We had several goals. We wanted to use giggy cameras because of their broadband ability. We wanted something that was lightweight and low power and at relatively low cost, and that would place a high amount of importance on modularity to allow for adaptability in different vehicles. Uses for a system like this include photogrammetry, meteorological and geological study, storm chasing, as well as a host of anything you want to do from the air. So we took a twofold approach. Michael and Ben worked on the Arduino sensor package. They incorporated a GPS, IMU, radiation sensor, and a weather station that captures humidity, wind speed, temperature, and the like. The system is very robust. It writes everything to an SD card as well as putting it out serial to the second half of the package. So the second half of the package is the giggy camera / Windows board, which Kenny and I worked on. It's a micro ATX board that fits inside of the aircraft. It runs an i3 processor with 8 gigs of RAM to handle the camera's outputs. We bring in information via serial from the Arduino package and tag each individual frame with data so that photogrammetry software on the ground can then very quickly and efficiently put together a file from the information that we've gathered. All of the data is written into a hard drive that is also stored inside the plane. The board comes with a special adapter board allowing us to run on several lithium-ion batteries. We found that the computer will actually outlast the batteries that power the aircraft. So we were worried at first about issues with that, but we managed to make it power efficient enough that it can handle extended flight times if it needs to. As far as accomplishments, we have successfully test flown the aircraft with the system. We have videos and photos. And in fact, if you come by our booth, the aircraft is sitting there. Welcome to poke around, see what you can find in there. We can do multiple cameras, including hyperspectral and thermal. We are primarily limited by the payload the aircraft can carry. Our system is designed to be modular in the sense that if you want to run one camera that's low resolution, one camera that's high resolution, and one infrared, you can. If your budget limits you to just one camera, that's fine too. There's no software changes that have to be made for that to work. It's all plug and play. Also, the system is designed to be easily replicated. So we have currently one test vehicle that is fully operational, but it's not a stretch to say that within a week we could have several more systems put together, assuming that you have the components in stock. And you could have it mounted in both helicopters and larger airplanes, and because of the battery supply, you can run for quite a while. Also, one important note, we have exhaustive documentation. That was one of the things that we focused on to make sure that the process would be completely reproducible from start to finish by anybody, any technically competent person. So, like I said, we've had a successful test flight. Please come by our booth and take a look at the video and the stills and the plane itself. And now I'll go open to any questions.
What was the original motivation?
So it was part of the UTV project. Dr. Gans and Dr. Larry, who's not present here, he works over in the physics section. That's their icon right there. And they want to do photogrammetry with it. So they want to put up, as well as multi-spectral cameras. So that was the original motivation. There are similar systems that do sort of the same thing, but they tend to cost well over $1,000, sometimes well over $10,000. Whereas after some trial and error, I think that it's safe to say we could reassemble our system somewhere sub $500 per unit. No, but that's without the cameras, right? The cameras can go as far as your checkbook will. So,
what's the IMU measuring?
It generates the pitch, roll, and heading instead of quadrants, which is primarily because that's what the photogrammetry software requires. Well, that data is sent to the microprocessor that controls all the sensor stuff, and then is sent. That string is then sent to the camera control, and each time that a frame is generated, it numbers the frame, and it also tag the data string with the correct frame so that the software can match it up for photographic application.
And to give an example, our very first test flight, we had some technical issues, but we were still able, we ended up not being able to tag the frames. However, because we also write to SD, everything is stored in multiple locations, we were actually able to recreate the data on the ground by pulling the videos, or the frames from the hard drive and pulling the information from the sensors off of the SD card. And that was also one of the ideas, because that also allows you to run sans cameras if that's not relevant to the task.
Right, so